In the previous video of this series, we explored various ways how to create graphs from a codebase. We created a graph manually during code reading, converted outputs of other analysis tools into graph documents, which we could load into the graph browser, and we used the built-in tools of Plainion.GraphViz like package dependency analysis and call tree to analyze some source code directly. In this video I will show you how you can use Plainion.GraphViz and graph analysis as a crystal ball to foresee the future of a planned refactoring and the target design. Here's the idea. We are back in a project we already looked at in various previous videos. The test failure analyzer, which analyzes test failures from our CI/CD pipeline stored in a test database and then creates defects for our defect tracking system. One feature of this software is to send emails to the development teams in case some test failures could not be processed properly, for example due to infrastructural issues or insufficient data. As more and more features were added to this project over time, the codebase grew to a size where restructuring towards a more screaming architecture became necessary. If you are not familiar with this term screaming architecture, you can find some links in the description below the video. As a first step, we now want to separate the mailing feature into its own bounded context. Inside this bounded context, we still want to follow the separation of the clean architecture into use cases which contain the business logic, I/O, and the adapters. To get started, let's look at the structure and the dependencies of today's design of the mailing feature using graph analysis in Plainion.GraphViz. From Tools, we open Package Dependency Graph. Here we specify the location where the assemblies are located which we want to analyze. Let's remove the example cluster and specify the assembly pattern we are interested in. And we are not interested in any test assemblies. We enable create clusters for namespaces to see how well the code is structured today. And then we say create graph. After a few moments the graph appears, so let's hide this window here. And to see the structure between the namespaces, let's fold all clusters. As we are only interested in the mail feature, let's search for mail. And let's select all siblings. And let's do the same for this namespace. Select with all siblings. Now we remove all other nodes. We bring it into a tree structure. Now we can see that today's dependencies of the mailing feature with all other features. Let's clean up the graph a little bit by removing the test API. We are not interested in those dependencies for now. Let's remove just this node. Let's relay out the graph. And here we go. With just a few clicks we can visualize easily the dependencies of today's design of the mailing feature. And we can also easily identify a few things we want to clean up. For example, the bidirectional dependency between entities and mail, as well as the dependency from mail to some configuration namespace. To start the reorganization of the code, we open the cluster editor. We could now delete existing clusters and create new ones with a new name in order to get our screaming architecture, or we could simply rename existing clusters. For demo purpose, let's do both. So we could rename here this cluster to testfailureanalyzer.mail.io. And let's delete this cluster, as well as this cluster. Now let's create two new clusters. And we name the new one testfailureanalyzer.mail and the other one testfailureanalyzer.mail.adapters. If we now enable filter on identifier, we will also see the existing namespaces. We make sure that testfailureanalyzer.mail.adapters is selected, and then we type here gateways, click add, and all the types which were visible on the left side are now added to this cluster. We do the same with the other cluster, testfailureanalyzer.mail, and as we want to add the rest of the types to this cluster, we don't have to filter anything, we can just click add. We close the editor and we can see our new clusters here in the graph. Of course, this activity didn't change anything in the graph. It was basically meant for demo purpose, so in case, for example, you want to split one cluster into 2 or 3, then the cluster editor is a good starting point. Let's clear the selection again. And then look at the first dependency we want to clean up, which is between the entities and mail use cases. So we select both cluster nodes and remove everything else. We could now simply unfold both clusters to see which types are actually causing these dependencies. But this doesn't give us a nice view which we can easily analyze. So let's fold the clusters again, and let's remove some noise first. So we want to know why entities have a dependency to mail while we would actually expect it the other way around. So we click into the cluster and say remove all nodes which are not reaching outside. And then in mail, we are interested in those nodes only which are reachable from outside, so we remove those which are not reachable from outside. And if we now unfold both clusters again, we get a graph which is already much easier to analyze. If we now also use a filter to remove those nodes which are representing compiler-generated types and reformat the graph, we get a result which is even more cleaner. So what we see here are a few entities which depend on the class email address. So to remove the dependency from the entities namespace to the mail namespace, we can simply make the email address type a true entity which is globally available. So let's do this by right-click on the email address node and then clusters add this to test failure analyzer core.entities. Let's fold the clusters again and remove the filters. Let's fold also this cluster. And here we go. Now we see only this dependency between mail and entities, and it's going into the right direction. The mail feature depends on the entities, the core domain model of the application, and not the other way around. Let's follow the same approach with the other dependency we want to analyze and get rid of, which is from mail to configuration. So we select again both cluster nodes and remove everything else. We again want to remove all the nodes which are not reachable from outside. And then let's simply unfold this particular cluster to look inside. We can easily identify 3 direct dependencies. And as we did it in a previous step, we can simply deselect those nodes and move those into the mail cluster. This step also shows us a great benefit of the graph-based refactoring over the code-based refactoring. Once we move the direct dependencies to the new location, the graph updates immediately and shows us how formerly indirect dependencies became now direct dependencies. So we get pretty fast feedback on the consequences of a certain refactoring step. We could decide to undo it or just continue the refactoring until all direct and indirect dependencies are solved in the way how we want it. So let's pick this node as well and move it also into the mail cluster. Let's open the filter dialog again and remove those filters to see the full graph. Fold this one. Okay, let's analyze the mail feature and its dependencies. So we select this node and its targets. We do the same here. And the last one. We can easily see that the mail feature has only dependencies within itself or dependencies to the central core or the entities which contain the domain model. We clear the selection. We can also see that there are a few dependencies to the mail feature other than the main component, which is even not in that picture, and these dependencies could be a topic of a further refactoring step. And here we go. Just in a few minutes we have analyzed the existing dependency structure related to the mailing feature, and we have identified the aspects we want to reorganize. We have then simply reorganized the code towards the intended target design by moving the nodes around the clusters, and we got immediate feedback on the feasibility and consequences and could adapt our plan accordingly. If we now check the package dependency spec, we see that the code reorganization is well documented. The cluster names indicate the new location, while the namespaces still document the old location. This specification could now be added to the backlog and will serve as a perfect documentation how the planned refactoring should be performed. That's it already for this video. Now you know how you can look into the future of your software design using Plainion.GraphViz and the graph analysis. In the next video I will show you how you can write plugins for Plainion.GraphViz so that you can add your own analysis tools easily. If you missed the previous video and wonder which other approaches exist to create such graphs from your codebase, then watch this video now. And if you are interested in a systematic refactoring approach which can ensure the success of your next refactoring, then watch this video next.